some science.
I do.
Okay, so we're going to talk about gases. Okay, what's a gas? Give me an example of a gas.
Air.
Air, that's a good one. Let's use air because there's lots of air around, okay? Now, what can you do with gases that you can't really do with liquids and solids?
Compress them.
What else can you do? If you can compress them, you can
Make them bigger.
make them bigger. And the technical term for that is
Expand.
gases can be compressed and they can expand, and along with that comes a really special property. And that's what we're going to explore. If you start with a bubble of gas and you compress it, what happens to it? Besides getting smaller.
The temperature increases.
Do people agree with him? Do you think he's
Yeah.
right, wrong? You agree?
I agree.
Well, he said it so convincingly, you have to agree. There's only one way to find out, right? Time
Take
to
air
do-
and compress it.
Take air and compress it. Let's do an experiment. So I happen to have a tube here, right?
Yeah.
What's in the tube?
Air.
It's full of air, that's right. And down at the bottom, we have a device called a thermocouple. It's for measuring temperature. What's the temperature of the air inside the tube?
23 degrees Celsius.
23 degrees Celsius. That's our temperature indicator right there. When we give you the signal, I want you to hold on to this in one hand and push really hard with the other hand.
Okay.
And let's see what happens to the temperature. Okay, on three. 1, 2, 3.
Oh, 34.
Ooh, up to 29 degrees. Well, the record is 50.
Okay, I'm beating it.
If he goes over 40, give it 41. Hey, give it up for Lucas. Ooh.
40.
Where did we get to?
41.
Okay, 41. So you took it from 23 to 41. The question remains, why was it getting warmer? Why, when you're compressing the gas, why should it get warmer? Did you have a heater? Did you have a lighter? Did you have like some sort of burner up your sleeve?
No.
No. Were you adding heat to the system?
No.
No.
Just compressing it.
Just compressing it. But what were you doing in the act of compressing?
Adding energy.
Exactly. What were you doing? You were doing work, right?
Yes.
There was no heat source, just the compression. But that work, by putting the work into the system, you're adding energy to the molecules, and that drives up their temperature, drives up their heat content. Anybody been to Calgary in the winter? What's a very distinctive weather phenomenon they get in Calgary in January in the winter?
Chinook winds.
Chinook winds. And what is the characteristic of a Chinook?
In the middle of winter, I guess the wind would come through and it would elevate the temperature. And
Calgary's down here. What's right beside Calgary?
Mountains.
Mountains. So the air has to come over the mountains. It's way up here, right? When it reaches the end of the mountains, what does it do? It goes down. When it goes down, the pressure increases, and what happens to that air?
It gets warmer.
Warms
It
up.
gets warmer. The Chinook is just this happening in the atmosphere. What happens to the temperature of a gas when you compress it?
Increases.
It increases. So, what do you think is going to happen to the temperature of a gas if it expands? It
Decreases.
decreases. Well, how are we going to find out?
Scott's gonna have to do some more work.
I think we better try another test. I happen to have a couple little canisters like this.
CO2.
No, it's actually nitrous oxide, N2O. And so what I'm going to do, we're going to allow the gas to expand very suddenly out of this, okay? And what's going to happen? What do you think is going to happen to the
It's gonna
temperature of the
freeze. Totally gonna go ice cube.
canister? Okay, well, let's give it a little punch here and see what happens. What do you see?
Frost.
yeah.
Frost. If it's frost, what's the temperature got to be?
Zero.
It's very cold.
It's very cold. It is.
Starting to get some smoke coming off.
Yeah, you're getting condensation. You're getting cold air, condensation out of the air pouring off the bottom there. And you can see how frosty it is on the bottom. We've dropped the temperature from room temperature down to well below zero just by expanding the gas there. Now the gas is expanding. What's doing the work?
It's the gas, the molecules, I was going to say.
That's right, the molecules of gas themselves. They're doing the work to expand against their environment. And if they're doing that work, if they got to use energy to push out, there's only one place for their temperature to go, and that's down. Real world application of that?
Fridge.
Yes, exactly. A fridge, when you compress a gas in the compressor and you expand it, that's how the fridge cools down. If you take something like nitrogen and expand it extremely fast, you can chill it down to almost 200 degrees below zero and get liquid nitrogen. That's how you get liquid nitrogen or dry ice, by expanding those gases very dramatically.